Chapter 2, midterm review. Here we go. We started talking about distributions and looking at location within a distribution. And we started off by talking about percentiles. And percentile is the percent of the distribution that's less than or equal to a certain value. Less than or equal to a certain value. So for this, 86. 86. There's 25 students. This girl Jenny scored an 86. So how many people scored less than or equal to 86? Well, only 3 scored above, so 22 out of 25. So she'd be at the 88th percentile. 22 out of 25 is 88. Yeah, 88. So she's at the 88th percentile. All right. So then we kind of talked about all right, being able to figure out percentiles, but not just from a concrete set of data. What if we have a cumulative relative frequency graph? Whoa, that was a whole lot of words. Cumulative relative frequency. So cumulative percentage. This is really percentile. When you have a cumulative relative frequency graph, this is a fancy way of saying this is a percentile graph. That's all this is. So when I have that, they might ask you, oh, what score or what age represents the 60th percentile? So, and down, maybe about 56, 57 years old. They could ask you about the IQR. So I'm going to find that's about 70%, 75th percentile is about maybe 59, 25th percentile is about 51, 59 minus 51 is, I don't know why this is hard, it's 8. So the IQR is about 8 years. That means the middle 50% of the president's age at inauguration varies by about 8 years. So that's how you're going to use a cumulative relative frequency graph or a percentile graph, because that's going to give you the percent of the data that's less than or equal to that value. All right. That's talking about that. Oh, then we got into z-scores, and we've done a bunch with z-scores since, so this is not going to be anything really groundbreaking. Z-scores we're standardizing. How do you standardize? You subtract the mean, you divide by the standard deviation. So we did that. So there's your formula. What this allowed us to do is to compare apples to oranges. So it will allow you to compare one student's score in chemistry to another student's score in math and see who did better relative to the class. A couple things to keep in mind with z-scores. Z-scores measure in terms of standard deviation units. So the units for z-scores are standard deviations. If you have a positive z-score, you're that number of standard deviations above the mean. Negative z-score, you're that number of standard deviations below the mean. So if I have a z-score of negative 0.5, that means my height is 0.5 standard deviations below the average height. So that's that. So you have to be able to calculate and interpret a z-score. Oh, then we got into transforming data. This is where we did our shifting and our rescaling. So let me do this. Oh, beautiful. Okay, so say we have a set of data, and what's a good context that we use quite a bit? If I could remember it. All right, I think this is, don't quote me on this, 9/5 times the Celsius plus 32. I think that's the formula we use to convert from Celsius to Fahrenheit. So say we have a mean of the average temperature in terms of Celsius is 10 degrees Celsius. Let's say the standard deviation is 4 degrees Celsius, and the minimum value is negative 2 degrees Celsius. Okay. And they might ask us to find these in terms of Fahrenheit. So what I need to know is this a measure of center, variability, or location? Mean is a measure of center. Standard deviation is a measure of variability. Minimum is just a measure of location. So I'm going to make a little chart here. We have shifting and rescaling. And we have center, variability, location. Adding and subtracting affects center, and it affects location. It does not affect variability. Here's a perfect reason why. Here's a histogram right here, okay? If I just move my textbook left and right, if I were to add or subtract, it's not changing the variability of this graph. These numbers are shifting, like up into the hundreds maybe, or down into the negatives, but the distance between the data is not changing. All right, for rescale, that's going to make the data it's going to make the data wider or narrower. So that's going to affect center, that's going to affect variability, that's going to affect location. So this is the key one. When you add and subtract, it does not affect measures of variability. Measures of variability, as a reminder, standard deviation, IQR, and range. So here goes. Our mean was 10 degrees Celsius. I'm multiplying by 9/5. That's a rescale. I'm adding 32. That's a shift. So my new mean would be 9/5 times 10 plus 32, whatever that equals. Standard deviation is a measure of variability. So it is affected by the rescale, but not the shift. Minimum is a measure of location. So that's affected by both the rescale and the shift. I don't care what these answers actually are. That's just the idea there. Okay, so that's really it for section 2.1, talking about percentiles, z-scores, how to read a cumulative relative frequency graph, and then how transforming data affects measures of center, variability, and location.